And today I think she's going to talk about Interop, the Ethereum economic zone. So we all know that there are, Ethereum has fragmentation problems. So so the EEZ aims to allow different layer 2 networks to interact with each others and within the Ethereum mainnet with a single transaction without requiring more bridges. So I'll let Friederike to continue.
Okay, fantastic. Who here already knows about, can you hear me without the mic? Then I'll speak without it. Perfect. Who here already knows about the Ethereum economic zone? Quick show of hands. Okay, that's actually not very many people. Fantastic. I'll give you the TLDR first. Okay, so the Ethereum dream was very much letting different people build different protocols that wouldn't just execute once they were deployed automatically, but that could also interact with all the other protocols, right? So kind of if I gave you a platform and you could build an oracle on it, or a stables protocol, or a DEX, or bridge market, in isolation, any of them are somewhat useful, right? But the real magic actually happens when you let them build on top of each other, when you kind of let them, when you actually let them integrate into one another and call kind of each other's parts, right? So kind of the interoperability that you get by operating on a permissionless system, this is a key part of the value proposition. And this was that was the key promise of Ethereum that kind of lured me and many others into the space when Ethereum first came up. So it's not just permissionless access, it's permissionless innovation, right? So kind of even I build a protocol, someone I don't like can build on top of it and there's nothing I can do to stop it, right? Okay. I already talked about this, so everything can connect to everything, and then kind of we broke that, okay? So there's a reason why we broke that. If you look at transaction fees over the years, so kind of back in the day, kind of transaction fees were near zero, and then kind of here we had a couple of ICOs in 2017, including ours, and then kind of we had DeFi summer, and you see how much the average transaction fees spiked. So this is just the average transaction fee. Think of it as 100,000 gas or something, right? And kind of you can see that it actually went up to $50 for a pretty bog standard transaction. Obviously, this was not sustainable. This was not this was not a feasible cost. And then look at kind of the numbers of L2s that we had at the same time. Obviously, in the beginning, we had none. We also had very few transactions total. And then kind of fees spiked. And the magic thing about this graph is actually, if you look here, look where the transaction fees are now. They're almost the same level as they were back in 2018, okay? And the reason is not that we figured out scaling on Ethereum. So kind of if you look at the actual throughput, it's gone up a bit with block gas limit and some optimizations, but these were minor, okay? So kind of the reason why the transaction fees have come down again is because basically we kind of put compute onto L2s, okay? So just kind of the compute that kind of used to happen on L1, most of that now doesn't happen on L1 anymore. And this broke the composability that we had. So kind of this magic feature that you had one protocol and it could call into another protocol and get a response and use that response within the same transaction. This atomicity, we call it synchronous composability. That now is broken, right? Because kind of like if you have one protocol on Ethereum mainnet and one protocol on Base and another protocol on Arbitrum and one on Gnosis and so on, the level of interoperability is dismal, right? Kind of like we've all bridged we've all waited and prayed, and we kind of, and that's kind of just sending tokens from one network to another. It's not even saying, okay, I use this oracle that's on a different network, or I use this as collateral for my protocol that's on a different network, right? So kind of we lost that. The question is, how do we fix this? And the Ethereum economic zone, easy, is the way to fix it. So, what's the cool problem here? So kind of if you think about it from a first principles point of view, what you actually have is you have a smart contract on one network that wants to do something to a smart contract on another network, and the smart contract on this network, so this chain, kind of has a perfect understanding of its own state. It has absolutely no insight into the state of this other network, okay? So what this smart contract needs to understand is what is the state of this network, and specifically the smart contract on this network at this specific block. And in order to kind of actually use this in the synchronously composable way, it doesn't actually have to understand this eventually. Eventually we can do. It has to understand this right now. So kind of with the experience that you have when you bridge, this is kind of the smart contract on one chain and understanding eventually what the state on the other network was. But in order to kind of to use it atomically, you have to understand it in what. The good thing is you don't actually have to understand it in machine time in the real time, but block time is very much discrete. So kind of you have a couple of seconds in which you have in order to prove that this is the actual state right now. So when I say instantaneous, I mean instantaneous in the sense of blocks, right? Okay, so the speed of verification is the thing that's the bottleneck here. And this is where zero knowledge proofs come in, okay? So, how much of you know how many of you know kind of like how is zero knowledge proof? I'm not gonna say it works, but how it operates. Okay, fantastic. That's at least half of you. So kind of a zero knowledge proof is basically it's an algorithm that can prove that kind of you applied a specific function to a specific set of parameters and kind of got a specific result. Okay, that's basically what a zero knowledge proof does. And verifying zero knowledge proof was always super fast. Okay, it's kind of like it's once you had it, I could say, yep, that's a proof. But creating that proof used to take a lot of time. A lot of time. I mean, basically, we've gotten much better at this, but kind of it used to take really long time, and now it's gotten progressively faster. So kind of now that we can kind of that we can actually create these proofs more or less in real time, kind of in block time terms, we can actually use this to prove the state of one network to the state transition function of another network to kind of see that kind of these can kind of interact now as if they were on a single network. Okay, so that's kind of the idea of the Ethereum economic zone. Kind of we've kind of positioned kind of like obviously kind of like this extends to L2s, to which it should obviously extend. So kind of if you're a network secured by Ethereum, obviously you should somehow be able to compose with Ethereum better than kind of like, oh, the bridge time is 7 days. But interestingly, it also goes much further than that. In principle, kind of like you don't have to be an L2, any network works. And there's one caveat, if you're willing, I mean, if you have a well-defined state transition function, which is probably given, and if you're willing to kind of prove your state, probably also given, because kind of from an engineering point of view, that's trivial. And thirdly, if you're willing to reorg if Ethereum reorgs, okay? So kind of like, because kind of once you have a transaction that kind of spans both, kind of like, say, I have a DEX trade where I have something kind of, I have token A here and I have token B here, and kind of I sell them for one another, right? So kind of like, if now this block gets reorged and that part of the transaction is no longer here, then this part also needs to disappear, right? Kind of the trick is you have both of them or you have none. Otherwise you don't get the atomicity, okay? So in some sense, the only thing kind of you have to do as a network is you have to say, okay, I promise to follow Ethereum. Ethereum is the lead chain. If Ethereum reorgs and there was something in there that kind of was a transaction that touched my state, in a contentious way. So kind of, I mean, most transactions would probably still be fine, but kind of if you just send tokens from address A to address B, you're fine. But if you touch state that gets changed, for instance, by using an AMM pool or something, then you might be reorged out, and then this transaction on this side also has to go, okay? So you need to potentially reorg if Ethereum reorgs. Ethereum doesn't reorg, so this is more of a theoretical problem. So actually, Ethereum actually hasn't had any reorgs in the past couple of years, let alone reorgs that were deeper than a block. So kind of it just doesn't happen. So kind of the number one thing that we're currently petitioning from the EF is kind of faster finality, just because it makes it so much easier for other networks to kind of agree that this is the ultimate settlement layer, and commit to following Ethereum. If Ethereum doesn't reorg, obviously that is way lighter on the engineering front. Okay, so let's deep dive into the architecture. So kind of, this is kind of synchronous composability. I already explained it in words. So kind of you have smart contract on chain 1 and smart contract on chain 2. And they're synchronous, the system is synchronously composable if the smart contract on chain A can call smart contract on chain B, get return value and use the same return value in the same block. You can actually loop these. So you can have nested calls that go back and forth as many times as you like. And I'll explain to you kind of like how it ultimately happens. So, okay, this is an example. I'll just skip through this. So kind of this is basically kind of an example of a user voting in a DAO, and the DAO checks whether they're on the whitelist. But it doesn't matter. So this is what actually matters. So this is what actually happens under the hood. So the core problem here is if you have two networks, obviously you have two sets of validators, or at least two different sets of entities that are allowed to build the blocks, right? So kind of they somehow need to coordinate, and this is kind of where the Ethereum economic zone is very pragmatic. So kind of it sources that out to the builders. So who here is familiar with builder infrastructure? Okay, one person, 2 people, fantastic. 3 people, fantastic. So building is the least understood core technology in Ethereum. Maybe that's a bit of a strong statement, but I'm pretty sure it's actually true. So even if you ask core devs, often they can't tell you how an actual block is actually built, okay? So the way that it happens is there is a public mempool, which is kind of like what most of us think about when we think about kind of how blocks are built. But only about half of transactions actually ever make it into that public mempool. Okay, why do you think that is? Why do people not just send their transactions into the public mempool?
MEV. MEV.
MEV is one. MEV is a very good reason. So kind of obviously it's all open. So kind of it's open and transparent, and kind of like anyone can kind of run you and arbitrage the shit out of your transaction. So kind of you don't want to send it to the public mempool. about half of transactions actually are what we call private order flow, and they go directly to the builders. Building is actually a very centralized business. So there's only 3 or 4 big builders that actually build all Ethereum blocks. And then kind of these blocks, kind of the information of how these blocks are constructed, this construction is sold to the validators, kind of the proposer, and the entity who is allowed to propose that block, okay? So, but the building itself, it's very centralized. So kind of there's a couple of big builders, and kind of if you don't want to send your transactions to the public mempool, you send them directly to a builder, either via white glove service or via a RPC endpoint that that does that for you. There's a second category of transactions that also never see the public mempool. That's intent-based transactions, right? Because kind of like there's no well-formed transaction there. Kind of like it's something that then kind of has to be figured out as you go, right? Okay, so what the builder then does, sorry, it's a short segue about building. What the builder actually does is it understands that when, okay, no, actually let me back up there. There's a second thing here that I should explain to you. When I have a smart contract on network A, and I have a smart contract on network B that I want to speak with, kind of my smart contract somehow has to have an understanding that my chain is not the only chain in the world. There's actually things outside of this chain. Obviously, this is not something that blockchains do or do well. So kind of what you actually have is we created a deterministic proxy address for every other smart contract on any network in the EEZ that kind of I will call it B star, kind of that's on every other network. So when I, as a smart contract A on network 1, want to speak with smart contract B on network 2, I don't actually call network 2 smart contract B. I actually call an address B star where there's actually nothing there, okay? But the builder understands that the address that I'm calling, where there's nothing there, actually is a standard for a smart contract on another network. And then kind of it looks at that network, like a jigsaw. It kind of looks at that chain and sees whether they fit together. So kind of when I say, okay, I send 5 DAI from here to there, and therefore I get 0.002 ETH back, it checks whether kind of this actually balances out on both sides. Okay, so kind of the builder is the entity that actually that kind of constructs these. It's called construction. It's an execution table, and kind of the builder builds this and kind of puts it in as part of the block. Okay, and that's the entire magic of what happens. So kind of for the dev doesn't actually have to know that you're calling a smart contract on another network at all. The dev just has to know. The dev doesn't have to know kind of like how it works. Kind of like it just clicks that smart contract. There's an automatic proxy address, and kind of the entire sophisticated block building is done by the block builder. The beautiful thing is, because this is very lucrative for block builders, because it also lets them get transaction fees from other networks, the block builders are all on board with this. So kind of all the big block builders are supporting this from day one. So that's kind of how it works under the hood. I'd skip over this. Yeah, so kind of this is kind of what the block builder does, the composer. Okay, then how far does it extend? So I've kind of just blankly talked about network 1 and network 2. Do they have to be Ethereum and L2? No, they can be L2 and L2, they can be L1 and kind of an alt L1. They don't actually have to be connected in any way. They don't even have to be an EVM chain. They can be could be Aztec or wasm-based chain, doesn't matter. So kind of, because it's all call-based, that you can connect with any other chain with a well-defined state transition function. Doesn't even need to be a public chain, okay? So it could be a consortium chain. It could be a nation-state chain where kind of your nation-state issues you your digital identity that is operated by your nation-state. As long as it's capable of proving its state to Ethereum, it can compose, okay? And this is, to me, this is the beauty of this approach. What I think we in this ecosystem have suffered from for too long is that we've kind of almost made it a purity pledge, okay? Kind of like it's Ethereum or nothing. So kind of if you don't want the credible neutrality that Ethereum affords you, you have no place to be here. But I think this is very misguided if you look at how the economy actually works. So kind of if I were a nation state, I wouldn't issue my debt on Ethereum. Kind of I would want to issue it on infrastructure that I somehow control. I still want it to interoperate. So I think kind of like all of these consortium chains that are basically silos that you can kind of access via a trusted API or kind of some sort of middleman infrastructure. That's probably not good for anything, but having a permission setup that can still synchronously compose with everything that's out there, that's kind of like having the best of both worlds. So I think this is this also plays nicely with kind of the entire crops thing, because kind of like Ethereum kind of doubles down on credible neutrality and kind of like being the ultimate settlement layer, being so unopinionated that everyone can kind of agree to settle on you, and then kind of you can have your own chain, your own area, your own fiefdom that kind of you can operate, but it can still interoperate with kind of the larger web. Okay, so I've talked about a lot. Oh yeah, it's orthogonal to pre-confirmations, and this works without forking L1, so kind of we've actually, there's a DevNet for this. This already works. The mainnet is going to be late this summer. Okay, so let me talk about, bridging. I'll give you examples, okay, just because this is really abstract. And I think kind of understanding what actually this powers, I think this is always kind of the best way to kind of to take it home, okay? So kind of if you look at bridging today, how many of you guys have bridged in the last month?
No.
Okay. how many of you cried while you did it? So it's so kind of the way that bridging today works is kind of like you send a token to a bridge contract, and it's locked. A message is generated. It's sent to the other network. Kind of you wait for relayers for proving for finality. Then kind of once you have finality, kind of you have a smart contract on a different network that now owes you tokens. So kind of you go to that smart contract, you claim your tokens, and then you have your tokens. Duh. Okay, that's how bridging works today. In the Ethereum economic zone, what you can do is kind of you have one transaction that kind of touches upon both things. So kind of you can bridge within a single transaction atomically. Yeah, that's the punchline. It's the kind of like there's nothing more to it than that. Liquidity. Okay, so today you have a myriad of pools on various networks that are basically the same token pair, and often they actually still have fluctuating prices, right? Kind of like it's a loosely coupled market. And kind of obviously kind of when the discrepancy becomes too big, kind of like there's arbitrageurs that kind of arbitrage it out. But kind of essentially kind of different networks behave like loosely coupled markets. Once you're in the easy, kind of chain A, B, and Z basically behave like one pool, like one market. None of these, so kind of these pools all stay on these networks, so none of them are moved. But because you can actually touch on them in a single transaction, you can now operate kind of on each of these states combinedly in a single transaction without any risk. Okay, so you automatically have the same prices, and kind of the entire easy operates behaves like a single market. Okay, yeah, and then obviously kind of this, okay, let me go back to this. Obviously kind of CowSwap would also understand this, right? So kind of CowSwap kind of currently abstracts away from you, kind of like which exchanges you use in order to exchange your tokens. Kind of when the EEZ is live, CowSwap will also understand kind of if the liquidity for the token you're trying to swap is much larger on a different chain, it'll just route it through different chains and kind of like resettle it on the chain that you're on, and it can do that in a risk-free way because it can now do this at home, right? This is okay. Composable finance. Okay, say you have ETH on chain A, you want to stake it on chain B, so you have to bridge it with going through the entire rigmarole that we talked about earlier. Then you have to, then you want to borrow against it on chain C and use that liquidity on chain D. That's a whole step, a whole ladder of steps here. Take you a long time, and you have many different payment modes here. In the Ethereum economic zone, you can actually do all of this rolled together in a single transaction, despite the fact that you're actually touching 4 different networks. Okay, this is an interesting example. So basically, it's global collateral. So kind of, if you kind of look back at these examples, they don't actually enable anything that isn't possible today. They just make it more convenient. Okay, kind of like bridging is more convenient. Liquidity is more seamless and more convenient. This is also argued, I mean, it's no question that it's more convenient to do this in one transaction. Can do it in 7 transactions if you want. This is something that currently isn't possible. So kind of say you have a portfolio across different networks, and you want a protocol to see that as one block of collateral rather than kind of different collateral on different chains. So kind of like currently, if you have say collateral on Gnosis chain and collateral on Ethereum and collateral on Base, kind of the Aave instance on Base and Ethereum and Gnosis always sees exactly what you have on that network, can see what exactly you have on that network, doesn't see what you have on other networks, right? But kind of once Aave natively understands kind of what you have on other easy networks, you can actually borrow against that global balance. And it's kind of like your bank operates. So kind of like if you've ever taken out a mortgage, they'll ask you for kind of like, okay, what assets do you have? And kind of say, oh, I have this house and I have so and so many ether, and then kind of I have a car, and kind of you can borrow against kind of the combined collateral here. Okay. And this works, of course, because Aave can also liquidate it across all of these chains in one transaction, right? There's no additional trust assumptions. Okay, global account control. Who of you operates safes sometime? Okay, how much do you hate rotating keys on different networks?
300 networks.
Yes, terrible. So kind of what you can now do in principle is kind of like you can say, okay, this is my safe, and kind of when I change my settings here, I actually want all of the other safes to kind of change the settings with it. So kind of like I have, say for instance, I have company and there's a signer on it, and that signer leaves the company. I want to remove that key and put in a new key. I don't actually have to do it on all 50 networks manually. I can do key rotation in kind of like one key rotation. I can also easily now do cross-chain recovery. It's very nice. So kind of you designate one safe, kind of the lead safe, and everyone else kind of just follows your lead safe. Okay, private identity global access. Okay, we don't have that today. So what this is in principle kind of like you can have your identity in a network that is optimized for privacy. So something like Aztec, right? But if you look at privacy enhanced networks, typically they are really bad at computing throughput. Okay, so kind of if you look at what TPS does Aztec have, it's dismal compared to, I mean, I love Aztec, but I'm a big fan girl of Aztec, but kind of if you don't want to do all your compute on Aztec, right? So what you now can do is you can have your identity on one network, and then kind of you can use that to authenticate against protocols on different networks. So kind of I can create a proof that I am allowed to access a say document or protocol or whatever based on credentials or reputation or membership or whatever, and kind of I create that proof on Aztec. My identity never leaves Aztec, but kind of the only thing that leaves Aztec is a proof that I am allowed to access this specific protocol based on the criteria that the protocol set. Okay, and this works because you can still compose even if the other network is not EVM based. So Aztec is very much not EVM based, but because it's all based on cards, still works. Yeah, so kind of identity stays on private chain, access happens as well. Same happens with consortium chains and Ethereum and public apps. So kind of like if you have a banking consortium and kind of like you want to do specific interactions with Ethereum, you can now do that in a synchronously composable way if you kind of choose to make Ethereum your lead chain. That is always kind of like the one caveat. You make Ethereum your lead chain, you can do anything that's on Ethereum, and you can actually, I mean, you can do everything in a completely trustless way. So kind of you can compose with Ethereum kind of by being a base chain, but you can also make faster blocks than Ethereum. Okay, so kind of Ethereum makes a block every 12 seconds. Kind of most of the L2s are much faster than Ethereum, so they have a block every second or even every 200 milliseconds or so. You can still do that. The only prerequisite is that kind of you only get the finality from Ethereum, kind of with kind of the cross-chain transactions. I mean, once kind of Ethereum is also final, but you can still have faster transactions on your own chain. If anything, kind of like if the block that kind of your chain is built on between Ethereum blocks, if this Ethereum block reorgs, you also have to reorg, kind of. But in principle, that's fine. You can. It's an engineering challenge. This we can do. So you can be faster than Ethereum. You can optimize for privacy. You can have constricted access. You can even restrict what kind of calls you're allowed to make in and out of your network, right? So you can say people on my network are allowed to use specific things on Ethereum, but not everything. So kind of it's yeah. So this is it's a pretty permissive and versatile architecture. Okay. So and this isn't theoretical. So kind of we demoed this in CAN at ECC. The DevNet is live, so kind of if you go to ez.io, you can actually see, it actually takes you to the DevNet. You can play around with it, and it's also not something. So kind of we're building it together with, so we as Gnosis, we're building it together with the ZIS team. It's being paid for by the app, but kind of all of the different companies you see here, kind of they and many more, they are committed to kind of supporting this from day one. Okay, so kind of all the examples I gave you with kind of collateral on Aave and kind of swapping on CowSwap and rotating keys on Safe and so on, this will actually work from day one, and it'll work because all of the major block builders are supporting this format. Yeah, I hope this was somewhat interesting to you. If you want to learn more, kind of you can scan this, kind of it'll take you to a form that connects you with our team, or you just go speak with Aman over there, who's our coordinator, or you go to eez.io, or you just talk to me. Good, fantastic.
From the audience?
Yes.
Yeah, so for example, like you mentioned the Uniswap thing, all the pools are fragmented. So I'm building a protocol on top of Uniswap.
Yeah.
I know how complex it is. So are there concerns? Obviously, all of those other protocols are brought in already. I didn't know about this really. So how do you answer the question of like, how does the increase of complexity work with security concerns, right? So I think anytime you increase complexity, there are concerns. Maybe there's some bug or something.
Yeah.
Everything's working fine right now. Yeah, how does that work?
This is an excellent question. So kind of maybe I'll answer it in two portions. So the first portion is, does it still work with Uniswap if Uniswap is not on that list? Absolutely. So kind of as a smart contract, you can't do anything against someone calling you, and basically it's not kind of, Uniswap doesn't have to understand that this exists in order for it to kind of partake in it. So kind of because of this entire deterministic proxy contract architecture, kind of it will just partake. The only thing that kind of you gain if you build your dApp with the easy in mind is that you can take advantage in your business logic of that. Okay, so kind of, so for instance, say Uniswap understanding that you hold a position on a different network and still letting you swap against that on a different network, that's kind of the business logic of the Uniswap app. But accessing a Uniswap pool kind of via an interconnect call from a different network, nothing that Uniswap can do anything against, so kind of they don't need to opt in for that to work. It's just about user experience for the user. Second question, does it increase complexity and thereby kind of introduce a security risk? Yes, absolutely. It's just as much as you have that anytime you interact with a different smart contract, right? Kind of like anytime you interact with a different smart contract, you have to think about, okay, is that smart contract, what does it do? Are there any backdoors? Kind of is it upgradable? Is it trusted, and so on? So with the Ethereum economic zone, it's very modularly built. So any network that partakes has to prove their state, and we recommend ZK proofs as the gold standard. But you can also do it with a TEE proof, so a trusted execution environment proof, which is basically it's a glorified multi-sig. You need at least two proofs, just to safeguard against bugs in specific prover programs. So that kind of, yeah, basically you need two proofs, but obviously you can have a malicious chain that then tries to kind of touch your state and do something with you. But whether you accept that or not, or kind of like whether you accept a specific token from a specific network as collateral, for instance, that is still your decision. Just kind of like you don't have to accept any random shitcoin. Now you have a second parameter, so kind of not just is it a random shitcoin, but is it a random shitcoin on a random shit network, and then kind of like it's, yeah. But in principle, it doesn't actually increase complexity by too much, and kind of like where it actually increases complexity, i.e. vulnerabilities in the guest program, which is the program that proves your client, that is safeguarded against by having to have two different proof systems. So kind of the ones that come out of the box are ZISC and SP1, and then a bunch of TE ones.
Thank you.
So, no, I think you mentioned at the beginning that is open source.
Yes.
Yeah, but where is the code of the framework, and under which license is it licensed? Where's the repository?
Yeah, if you go to eez.io, there's a GitHub link. It's all in there, so you can actually see us experiment in real time. It's free open source software. It's under, I believe it's under GPL license. I have to check. So it is publicly funded by the EF. We're co-funding it as Gnosis because we think it needs to exist, and kind of it will make Ethereum, it will level up Ethereum significantly. So kind of, but it's everything that is in this repository is free open source software. We have ideas how to monetize it later, but kind of, I mean, not this specific part of, but by basically kind of building things that kind of like make money for Gnosis. Anyone else could do this, so we're not in a advantaged position other than that we know exactly how the system works. But yeah, the thing itself is completely free open source.
Yeah, I'm definitely interested in it, and but maybe like we can talk later about this because I wonder if it's open source, people fork it and so on. Is then their competition?
You
They
don't-
might not agree with you and so on. So I'm very interested in like how you also want to like involve the community and you know the governance.
Yeah. Yeah, so 100%, so kind of ideas to minimize governance. So kind of in the beginning, kind of you can't do that, so because kind of it needs to be upgradable to some extent. Kind of making this have critical momentum in terms of community support. This is the be all and end all. So kind of the engineering. So kind of maybe I should be more humble, but we are excellent engineers. So kind of we can make this, we can build this, but kind of making sure that this is the standard solution. I think this is, as you say, this is the crux of the matter. The fact that kind of it's endorsed by kind of all of the DeFi protocols, they'll be using this from day one. It's supported by all the builders. It's financed by the Ethereum Foundation. Obviously, that helps a long way, and I think we're also known as principal builders of high integrity. So kind of, I think people understand that we can deliver this, and kind of the thing that we're actually building also doesn't have a direct upside for Gnosis. So kind of we've all kind of like ultimately it'll be a DAO decision, but kind of I'll do my darndest to ensure that Gnosis chain is the first legacy chain in the EEZ other than Ethereum. So kind of obviously for us being first is also a major advantage, because if you want the full composability of everything on Ethereum, but faster block times and lower fees, then kind of this is a pretty good pitch for you.
Great, thank you. All right, let's take a break. Oh, sorry.
Yeah, and what's the difference to layer 0 protocol? I don't really.
Yeah, so kind of, I mean, it's not a bridge protocol, okay? So kind of like it doesn't let you just bridge things. It kind of lets you create transactions that execute across state of different networks. So kind of it fully absorbs what layer 0 does, but it also does much more. So bridges hate this.
Great, all right, let's take a break, and then if you're interested in Interop and EEZ, please talk to Friederike and Amar. All right. Great, let's take a break, and there's some snacks.